Yes, welcome back to the session. In this video, I am going to discuss about law of conservation of energy for vertically projecting upward body. Okay, so look at the diagram here. Let us assume this is the ground. Okay, so there is an object which is initially located on the ground. Let us assume the position of the object is A. Okay, now what I'm doing here, I'm just giving some initial speed u in vertically upward direction. Okay, so whenever speed is given to this object, then definitely this object acquires kinetic energy, right? So let us assume at point A. So first of all, at point A, kinetic energy at point A is equal to half mu square, because I have given some initial speed to the object. Okay, so initially the object is located on the ground, so there is no vertical height. So therefore, potential energy at point A is equal to 0. So whenever potential energy is 0, we can easily calculate total energy at point A is equal to sum of kinetic energy at point A plus potential energy at point A. So kinetic energy at point A is half mu square plus potential energy at point A is 0. Therefore, total energy at point A is equal to half mu square. Okay. Yes. So whenever initial velocity is given to this body, then definitely this body will move upward direction, right? So we are projecting a body vertically upward, means acceleration due to gravity is negative. Okay, suppose after 2 seconds the position of the object reaches here. Okay, let us assume this height is small h from the ground, and the position of the object now becomes, let us assume, B. Okay, so whenever the body reaches to point B, first of all we need to calculate what is the speed of this object at this location, because initial velocity is u. At this location the velocity changes from u to v. Okay, so I'm writing here at point B. Okay, so at point B, I'm going to calculate final speed. For that, I'm using third equation of motion, v square minus u square is equal to 2as. This minus u square I'm taking right side. Therefore, v square is equal to minus becomes plus 2 into acceleration becomes acceleration due to gravity, that is negative. So minus g into small h, because height covered by the object is small h. So therefore we can write it as v square is equal to u square minus 2gh. Okay, so after getting this velocity, we can calculate kinetic energy as well as potential energy at point B. Okay, so first, kinetic energy at point B is equal to half mv square. Okay, so half m into v square formula is this one. What is the value? U square minus 2gh. Okay, now what is the potential energy at point B? Potential energy at point B is mg into small h, because this is the height gained by the body from the ground. Okay, now we know the kinetic energy as well as potential energy. Therefore, total energy at point B is equal to sum of kinetic energy at point B plus potential energy at point B. Okay, so therefore total energy at point B is equal to, kinetic energy formula is this one, half m into u square minus 2gh plus potential energy is mgh. Look at here, this half m is multiplied with u square and half m is multiplied with 2gh, right? So let's see the next step. Total energy at point B is equal to half mu square minus half m into 2gh plus mgh. Okay, so here denominator 2 and numerator 2 cut. The rest of the equation, total energy at point B is equal to half mu square minus mgh, because here minus will be there, and this is mgh plus this one mgh. So here minus mgh plus mgh cut, total energy at point B is equal to only half mu square. Okay, so this is the total energy at point B. Okay, so at this location still the body having a velocity v, so definitely it will keep on moving upward direction and finally reaches at this location. So this is the highest point attained by the body. Okay, so whenever the body reaches to a maximum height, so we can write it as this is the h max, maximum height. So from ground to the body acquires h height, capital H height. Okay, so we know that vertically projecting upward bodies maximum height formula h is equal to u square by 2g. So this equation is studied in motion in a straight line chapter itself. Okay, now let us assume the position of the object reaches to point C. Let's see what will happen. Just a second, I will go for next slide. Yes, when the body reaches to point C, so this speed becomes 0. V becomes 0 at this location. Whenever velocity becomes 0, what will happen? Yes, kinetic energy also 0, right? So now let us assume the object is at point C. So whenever the object is at point C, we can say that vertical velocity becomes 0. Whenever vertical velocity is 0, kinetic energy at point C is equal to 0. Okay, so what is the height attained by the body at point C? H is equal to u square by 2g. Okay, so this is the height acquired by the body. Now when the body reaches to a point C, the vertical velocity is 0. Okay, vertical velocity is 0 at this location. So due to this height, potential energy at point C is equal to mg into capital H. Okay, capital H formula we know, directly you can substitute here. Therefore potential energy at point C is equal to mg into u square by 2g. So this g and this g cut, potential energy at point C is equal to mu square by 2, or we can write it as half mu square. So this is the potential energy at point C. Okay, so we know the kinetic energy at point C and we know the potential energy at point C. Therefore total energy at point C is equal to sum of kinetic, sum of kinetic energy at point C plus potential energy at point C. So kinetic energy at point C is 0, clearly I mentioned, because vertical velocity is 0, plus potential energy at point C is half mu square. Therefore total energy at point C is equal to half mu square. Okay, so look at the diagram carefully. At point A, we have given some initial velocity, so it acquires the total energies in the form of half mu square. So due to this initial velocity, the body keep on moving upward direction. At point B also, the total energy becomes half mu square. Now finally, the object reaches a point C. At this location also, total energy is equal to half mu square. Okay.